Hello everyone, myself Ishwar. Today I'll be explaining you one of the important topic from Newton's laws of motion, and the topic is friction. We experience friction in our daily life each second, but we rarely neglect it. By the end of my explanation, you'll understand what is the friction in our life. Without the friction, the existence on the earth is impossible. So let's start today's discussion. For better understanding, let's take a box. It is on the table. The box is in the rest position. The reason for it is friction is acting on it. I slowly started applying force on it. It's not moving. I further increase the force. It is about to move. I further increase the force. It is in the motion. The question is there is a friction when the body is in the motion? Yes, the friction acts when the body is in the motion also and when the body is in the rest. Friction is a force that opposes the applied force in the relative tendency of the motion or the relative tendency of the motion of the body. So, we understood what is the friction is. Let's understand in which direction the friction acts. Friction acts in the opposite direction of the applied force and it is tangential to the surface in contact with it is. So I am applying force in this direction. So the friction force acts in the opposite direction like this and it is tangential to the surface which it is contact with it. Now we understood the direction of the friction also. Now let's understand, is there any friction force that is applied by the table on the box? We know that there is a friction applying by the box from the table. But do we know that if there is a friction which is acting by the box from the table? Yes, there is a friction force which is acting by the table on the box. According to the Newton's third law, we know that every action has an equivalent and opposite reaction. So every forces exist in the couple, the pair. The friction will be acted by the box on the table. In the same way, the friction will be acted by the table on the box. Now, we understood that friction can happen when the body is in the rest or when the body is in the motion. When the body is in the rest, the friction force which is acting is static friction. When the body is in the motion, the friction force that is acting is kinetic motion. Static friction is represented by F of S. Static friction, the job of the static friction is to make the whole body to be in the rest. And it is completely dependable on the force that we are applying it. It is like if we are applying small amount, the static friction also opposes in the small. And when we apply a larger amount, the static friction also will be in the large. It is completely variable depending on the applied force. Let's apply the maximum static friction, which is nothing but limiting friction. So if I started applying force, it is not moving. But if I still continue to increase the force, it is about to move. It means the maximum static friction is the static force which is acting just before the movement of the object from rest to motion. It is represented by F of S max. And we know that static friction is a variable force depending on the applied force. We cannot directly find the Fs, but we can find the Fs max, which is limiting friction. Now let's take another example. Imagine you are pushing a big box in front of you, but initially when you are pushing, you put maximum effort to bring that box into motion, and when the body gains the motion, you start applying a little force less than compared to the static friction, and the friction and that friction, the reason for the less impact for the motion for you pushing less is kinetic friction. Once the motion is gained by the object, it reduces the friction, and the friction which acts when the body is in the motion is called kinetic friction. Kinetic friction which acts when the body is in the motion. Now, it is represented by f of k. Now, let's understand formulas for both the static and kinetic friction. As we discussed earlier, we cannot directly get the formula of f of s, but we can find the f of fs max. Fs lies in between greater than or equal to 0 to less than or equal to Fs max. Fs max is directly proportional, static friction is directly proportional to the normal force which is acting on it. The normal force acting on it is directly proportional to the weight that is by the box. We can write it as F directly proportional to N. I would like to add one more point here is static friction is not dependent on the area of contact. The friction force applied on while I am moving like this and the friction force that I am acting while I am moving this will be same. It is not dependent on the area of contact. It is rather dependent on the surface of the contact which it is, and it is dependent on the normal force. Therefore, we can say that F is directly proportional to N, and when we remove the proportionality symbol, we get F is equals to mu s into N, where mu s is the proportionality constant of static friction. Now, let's in the same way, let's try to find the formulas for the kinetic friction. So, in the same way, kinetic friction, when the body is in the motion also, the normal force will be acting, and because of that, we can also say that force is directly proportional to the normal force acted on the body. So, we can write it as F is directly proportional to N. By removing the proportionality symbol, we get F is equals to mu k into N, where mu k is the proportionality constant of kinetic friction. So, we understood what is the friction, what are the types of friction. But in the kinetic friction also, there are two different types. One is the sliding friction, which means when we are doing like this, we are sliding one object on the other. That is sliding friction. When we are rolling something, that is called rolling friction. So, kinetic friction is further divided into sliding friction and rolling friction. When you observe, we need more force to slide an object like this on the table. Rather, if you imagine a 4 wheels down here and try to move this on this table, we need less force compared to the force that we required for sliding this object directly without the wheels. So, it is therefore can be concluded that the force required to move an object when compared to in between the sliding and rolling friction requires less amount of applied force. The reason why rolling friction requires less amount of force to move the object is rolling friction a wheel has a less contact area with the surface. So, it experiences more movement when compared to the sliding. Contact area is dependent in the rolling friction. That is why we call wheel is the greatest invention of the human mankind. Okay, now let's understand a plot between force applied and the friction. So, in the beginning, when the body is trying to move, when we apply a first starting force, it will keep on increasing. This straight line represents the body is in the rest position. But when it reaches the maximum static friction, it about to start. Then when the force will be maximum. After it crosses the maximum kinetic friction, it will maintain a straight line. In the kinetic friction, it is constant throughout the motion. The force is constant throughout the motion in kinetic friction. So, I would like to conclude that with my explanation, you understood what is a friction, what are the types of friction, what are the different types of friction in kinetic friction, and then you understood all these basic fundamentals. I would like to conclude that with understanding the basic fundamentals, we can build up and solve a bigger problems. In the next sessions, we'll discuss more about the in-depth problems. Thank you all. Have a nice day.